So you may be wondering, what is a generic in Java? And this concept is one that often confuses beginning Java developers, but I think a real easy way to explain what a generic is to basically say it's a way that we can write some code that doesn't depend on a type. It's independent of a type. And what I mean by that is that if you look at this example that I have below, you can see I've got some different kinds of houses. I've got what would typically be a person house. It's a small model version, but we could think of that as a human house. I've got a dog house here, and I've got a bird house. Now, you might write some code in Java that incorporates some of the things that have to do with a house. You might have it have some methods to open a door, open a window, or let someone in the house, let someone outside of the house, count the people that are in the house. Some generic code that applies to any kind of house, anything that provides shelter that some animal or person lives in. Now, if you don't have some way of specifying that code to work on any kind of type, then you're going to have to write a specific class or a specific type and repeat that code for a dog house, a person house, and a bird house. And you could create an inheritance hierarchy and try to reuse some of that code in that way, but a generic allows you to do this a lot more efficiently. It allows you to basically create a house and then specify the type in your code instead of trying to make a specific type of house. So for example, using generics, we'll create a house of type question mark. And when you want to create that house, when you want to use that house to create an object of that type of house, it'll be of type, and you'll specify what the type is. So person, dog, bird, and then that house will be specifically customized for that type. And we'll get into the code and I'll show you a little bit more about what that means. But just as a concept, the way to think about this is just some way of being able to create a class that will operate on different types. So let's talk about the kinds of generics that exist in Java. You basically have two main ways that you can declare a generic in Java or use a generic. The first is at a class level. So if we create a class level generic, that's kind of the example that we had talked about with the house, is you're going to make a house of a generic type. We don't know what the type is. We don't know what that house holds. It might hold a bird, it might hold a dog, it might hold a person. We don't know what the house type is, but we're able to create a class that specifies that it's going to use whatever type that the programmer that wants to use this house says in their code. The way to think of that is a class of type T. T is kind of what we use to represent a generic type, or whatever type is going to be used for that class. So it's a class of some type, a house of type T, and we'll specify T. So you might have a house of type dog. That would be a dog house. The other way that we can create a generic is at the method level, and it's basically the same thing, except instead of where we're declaring our class and we're using a type that is going to be the type throughout that class, with the method level, we're just declaring a type for a parameter. So one of our parameters, or more than one of our parameters, can be of a type that we specify, a parameter of type T. So that means that this method is going to take in some variable or some parameter, but we don't know what the type is until it's called in code. And at the point that it's called in code, then we're specifying what the type is. So this method is generic in the sense that it'll operate on multiple kinds of types. And a good example of this is if you think an add method. An add method should be able to operate on integers and decimal numbers and even strings. If you created some kind of generic add method, you wouldn't want to have to make that add method be written for every single type. You'd want to be able to create one generic add method that would work for all kinds of types. Same thing with maybe printing out to the screen or printing out to a printer. You wouldn't want to have to create a different print method for every single type when it's going to do the same thing. So let's look at kind of an example here that's going to maybe clear things up a little bit more. I know this is a little bit confusing, but if you bear with me here, we're going to get this figured out and you're going to understand generics by the time we're done here. So a good thing to do is to look at what would our life be like without generics in Java. So this is also a good time to tell you that all classes in Java inherit from object. This is sometimes the first thing you learn about programming Java, but up to this point, we haven't really needed to know this information, so I don't think it's a great place to start. And I'm telling it to you now because this is the first time that we're actually going to really need to know this. And the reason why this is important is because if you wanted to create some kind of generic method or generic class without generics, you could basically make that class operate on object. Since you know all types inherit from object, all types are essentially objects in Java, that method or that class will work on any type because it's going to be an object. So as long as you use object. Now the problem with using object everywhere is it's not very specific. Object could be anything, so you're going to lose the ability for the compiler to tell you if you've mismatched types, since it'll take any type. So let's look at an example of this and why this could hurt you. So I've created our house example here. You can see I'm creating a new house, I'm creating a new person, and I'm going to call a method on house add person. Now, in this implementation, I'm not using generics, so my add method is going to take an object, and this is in order to make it so this house would work with a dog, with a cat, with a bird, with a person, so I don't have to rewrite this code. Otherwise I would have created a person house, a dog house, but this house will operate on any object. So I could put a person in there with add. Then I can remove a person, and you notice I have to use this special operator called a casting operator. I'm telling the compiler that what you get out from here is of type person, because I know I put a person in, so I know I have to take a person out. Because what this method, if we looked at this house.remove method, we'd see that it returns an object. And that's because we're making it so that this house class could work with all different types. So this is without generics. Now let's see what happens when we try to add a dog to this house. Well, there's going to be a problem here because we are writing some code that's operating assuming that you've only added a person to the house. And we have to do that because we have to have some way to get the person out. So we have to explicitly type or cast that person back out when we do house.remove. So I've created a dog here. I've done house.addDog, and this isn't a problem. The compiler was not going to complain about this because remember, in this add method, we're using object. And we're doing that to make this somewhat generic without using generics. Now what's going to happen, we're going to get a runtime error when we try to remove that dog from the house because we're going to try and cast it to person. So it's going to give us a class cast exception at runtime, which means when our program is running, that's the only time it's going to figure out there's something wrong, and it's going to blow up. It's going to crash the program. So this is really bad. And this is because we don't have a way to specify to say, yeah, this instance of the house that I created, I only want it to hold people. We have to rely on other programmers using this class once it's created, using this object once it's created, to only put one type in there and only remove one type from there. If we mix them up, we won't have any way to know which type is in there. And even if we did, it would create really messy code. So now let's look at the same example using generics. Generics are basically going to give us some guidance here in this case that allows the compiler to know what we intend to put in our type, or what we intend our type to be. So in this case, we've got our house again. And this time you can see I'm using the syntax for creating a generic, and we'll get into this when we get into the code, is I'm using these angle brackets person. So I'm saying create me a new house of type person. So this house is only going to hold types of people. So I create my new person, I add the person to the house, which is fine. In this case, this signature for this add method would look a little differently. It would have a T for the type, but ignore that for now. And then I can remove the person. Now when we get to the dog example here, we're doing the same thing here. We're adding the dog, and actually what's going to happen here, we're going to get a compile error for either of these things. We can't do a house.addDog. That'll give us a compile error, and if we try to do a house.remove and assign a dog to a person, we would get a compile error. We wouldn't be able to do that, or we wouldn't have been able to put the dog in the first place. The house.add is going to stop us from doing that. If we try to remove something from there, it's always going to be a person because it's kind of a guard here. The add method is only going to accept a dog because when we declared our house all the way up here, we said that this house is of type person. So that's the basics of generics, and it's really not going to make a huge amount of sense until we put it into a real usage, and that's what we're going to do next.